Several species like thresher sharks and ocean sunfish that preferred warm tropical waters were spotted almost 200 miles away near Alaska because of the blob. Australia's 3.5 lakh kilometre long Great Barrier Reef suffered a bleaching event when the Australian Bureau of Meteorology recorded its highest ever sea temperature. Prices of fish tripled in Mumbai, India, due to a drop in fish catch volumes threatening the livelihoods of the famous Koli community. What do you think is common between these three seemingly unrelated events in different parts of the world? The answer is marine heatwaves, which are happening due to ocean warming and other factors like high-pressure systems. Marine heatwaves should not be misunderstood as waves traveling over the ocean. These are extremely hot patches of water over the surface and subsurface of the ocean, majorly attributed to human-induced global warming. The first major marine heatwave was recorded off the coast of Australia in 2011, which caused mass bleaching of reefs and a southward distribution shift in fishing communities. They are detrimental to the marine ecosystem and specifically corals, which lose color due to warming ocean waters.
These kind of marine heat waves can be detrimental to the marine ecosystem, the seagrass, the corals. There is a massive coral bleaching going on when these heat waves happen, to kelp and also to marine fisheries and aquaculture.
In the Indian subcontinent, there are two regions where marine heat waves occur specifically: Western Indian Ocean and North Bay of Bengal. When the temperature rises on the ocean surface, it can increase anywhere up to 3 to 4 or even 7 degrees Celsius. Not only do these heat waves cover a large area of the ocean basin, they can last anywhere from a few days to weeks or even months. Marine heat waves are impacting the subcontinent by affecting monsoons and cyclones. If we take into account cyclone data since the 1980s, it shows that the characteristics of cyclones are changing over time. This is majorly related to ocean warming because a requisite factor for tropical cyclones to form is warm oceanic waters where the temperature is above 28 degrees Celsius. This is reflected most in the Indian Ocean, which is the fastest warming ocean basin in the world. These warm waters provide more moisture and heat for the cyclones.
Basin-wide warming is happening in the Indian Ocean, and this is going to continue at a rapid pace in the future. So far we have seen large-scale warming of up to 1 degree Celsius. In some regions like in the Arabian Sea, we see up to 1.2, 1.4 degrees Celsius. And future projections shows that going up to 3.8 degrees Celsius if we take the high road business as usual emissions by the end of the century. That's between 2070 and 2100.
As a result, cyclone numbers are going up, which is more evident over the Arabian Sea. Since the Bay of Bengal is naturally warmer, already there are 2 to 4 cyclones forming there every year. But the Arabian Sea is reaching a similar status right now, which supports active cyclogenesis. Cyclones have increased by over 50%, while their duration has increased by 80%, like Cyclone Tokte, which started from Lakshadweep Islands and hurled past Kerala, Karnataka, Goa, Maharashtra and made landfall over Gujarat. Although it should have died there because of friction with land, its remnants even reached New Delhi and Nepal, where it caused rains. This increase in duration of cyclones is posing tremendous risks over the west coast. When marine heat waves happen during June to September, they impact the monsoon as well in some parts of the country. These huge patches of warm water change the way atmospheric circulation works. As a result of more heat and moisture, convection rises from it and leads to subsidence over another region, either land or water. It also creates a low pressure below, which pulls in a lot of winds. When we have warmer waters in the Western Indian Ocean, the winds are pulled towards the low pressure systems rather than going towards the mainland. This in turn weakens the monsoon.
So when we have warm waters in the Western Indian Ocean, which is one region where marine heat waves are occurring, and India is there, the Western Indian Ocean is here. It pulls a lot of winds the moisture-laden winds towards the Western Indian Ocean. So instead of going to the mainland India, the winds are pulled to that low pressure created due to the marine heat waves. And that weakens the monsoon when we have the marine heat waves.
Sea levels are rising every decade because ocean waters expand as they get warmer, which is also increasing the frequency of marine heat waves and subsequently cyclones. Cyclones are bringing more rains than before, which increases the flooding along the coast. This can also be accompanied by a high tide, which is a natural event, and storm surge, which is caused by cyclonic winds. These compounded events affect human lives, infrastructure, and food security. India is the 7th most vulnerable country when it comes to climate extremes. So it becomes imperative to invest more in the Indian Ocean observing system to closely monitor changes in the Indian Ocean. When data on marine heat waves was recorded in the Bay of Bengal just before cyclone Amphan hit, it showed a temperature of 34 degrees Celsius, which was unheard of in global open oceans. But what should be done to better monitor these marine heat waves? We need more surface-based monitoring systems that can accurately tell us the warmer than usual spots. In the case of cyclone Amphan, satellite data only showed that the sea temperature was 32 degrees Celsius. This discrepancy could have been overcome with an ensemble of instruments to support INDOOS like floats, drifter buoys, and moored buoys, which help monitor temperature, salinity, and ocean currents. It takes at least 3 satellites to observe the Indian Ocean at all points in time, especially during a cyclone. Forecasting models have still not evolved to incorporate rapidly changing ocean conditions in their predictions. Climate models suggest further warming of the Indian Ocean in future. If carbon emissions aren't reduced, a 1 in 100 days event by 2031-2050 might become a 1 in 4 days event by 2081-2100. The 7,500 kilometer long Indian coastline, spread across 9 states and bordering an area of 2.02 million square kilometer area of exclusive economic zone in the sea, have a population of 420 million. Out of these, about 330 million live on or within 150 kilometers of the coast, while the coastal economy sustains over 4 million fisherfolk and coastal communities. The Indian Ocean is now a dangerous combination of events that will make the subcontinent increasingly vulnerable to climate change. If ocean observational arrays are not enhanced, the opposite might happen and damage to the Indian coast might be irretrievable. It is imperative for nations to step up so as to adapt to challenges put forth by a warming world.